Hi, Professor Naj. This is Christy Slater doing my assessment number 3 for my test. I'm going to kind of show you the items first and then I'll go through them all. There's my Logger Pro screenshot and my SCAW. I went ahead and made a nice little chart here to kind of have the data that we had calculated in class along with our equation up here. We have the delta x in meters, the Fn in newtons, and then the T equals 2 pi times the square root of m over k. In class today, we actually went through trying to get the units for k. And we ended up, when we worked it all out, we had t is approximately equal to m. We had the question marks with over the k. We ended up with the half of those. The kilograms canceled out, the meters canceled out. We ended up with newtons over seconds. We did the square root of second, and we ended up with seconds. So ultimately, the period or the time frame is in seconds. So the unit for that is in seconds here. You'll see that here. So again, we've got our meters, our newtons, and our seconds here. When I went through the numbers that we had taken in class and calculated them according to our equation here, the sixth one came the closest to 1 second, which was 0.758 seconds. But none of these values got up to a second. So I kind of played a little bit more with the formula. And with trial and error, I came up with t equals 2 pi times the square root of 0.625 divided by 23.84, which is our k constant here in this experiment, equals t equals 1.01 seconds. So that's as close as we're going to get with trial and error. Again, it did not match up with what we had come up with in class and the equation. But therefore, we would need the delta x to be 0.625 meters to get the clock to tick at 1 second. According to our assessment here. I'm going to kind of give you a better close-up of my Logger Pro. I've got my data here, my text box here, and then my equation with my slope. The slope is 23.84 newtons per meters. The y-intercept is 0.3050 newtons, excuse me. Our equation on the Logger Pro comes to Fs equals mx plus b, or Fs equals mx plus, the y-intercept there. So I kind of blew up this portion here. My summary is that we would need the delta x to be 0.625 meters to get the clock to tick at 1 second. I cited you in the Zoom sessions for all of this because you kind of helped me out with all of that, or helped us all out with that. Application, this activity shows us the relationship between the mass and the time, and I believe we could apply this in all aspects of life because everything is made up of particles. Wonderism, my question would be, in class we talked a little bit about gravity, how it all kind of intervenes in all of this stuff. I wanted to know if, why, if gravity is the weakest force, how does it actually govern the whole universe? How does gravity govern the whole universe if it is the weakest force out of all of the 4 forces? Now I'm going to hand over my my phone to my wonderful assistant here, and I'm going to show you how I made a clock myself. Hopefully I can do this without, so you can actually see it. I have whatchamacallits here because you say whatchamacallit a lot in class, and they are my favorite candy bar, and so I thought it was fitting for the end of class task that I would make a clock tick at as close to 1 second as humanly possible with whatchamacallits. I have done trial and error. I've done 1 whatchamacallit, I've done 2 whatchamacallits, and I've found that if I do 1.5 whatchamacallits, then it will get me to as close to 1 second as I can possibly get. So hopefully I can show you this all together. I'm maybe just gonna go like this in front of here. Try to be as steady as possible. I'm gonna get it going and then I'll get the timer. Can you get the timer too?
Yeah,
okay.
You're good to go.
Get the timer going too. Oops, let me kind of move it over a little bit here so I can get to it. There we go. Six, 7, 8, 9, 10. And so I came to 9.88 or 0.988 seconds, which is pretty darn close, but I want to try it one more time because through class I found that if we do it a couple times, then we get better results. So we're going to try it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now you can see we're at 1.06 seconds. So to me, that is as good as we're going to get, as close as we're going to get to 1 second. But now I want to weigh it because we want to see how many grams, because the whole point of this was to see grams. And since we have the clip and we have the whatchamacallits and the packaging and all the yummy goodness in there, I want to put all of it on my little scale here. So it comes to 87 grams. I got it.
Okay.
That's basically, for my clock, I need 87 grams of whatchamacallits plus the little doohickey there, whatchamacallit, whatever you want to call it, to make my clock tick at 1 second. Thank you very much for the wonderful semester. I appreciate all of the wonderful learning, and I hope that I fulfilled everything you wanted on the assessments. I'll just kind of zoom back in on the paperwork for you. And I'll include all of this as well when I submit too. Thank you, Professor Naj.